my name is Barkley Howe, and I am a director at CoStar Group, and I am thrilled to be here to talk to you about a little bit of one of my secret shames, which is that I am a history major, actually, and so I tend to look at things in terms of a view of history. So I'll give you a quick little overview of who CoStar is. You hopefully know a little bit already, but I'll give you a quick little bit about that, about my background, and then we'll jump into what I hope you guys find to be a pretty interesting talk. So a bit about me, as I said, I'm not trained as an engineer. I've been in the field for 20 years. And I started off, I was a history major. It was the liberal art that I was least bad at. And my parents said that I should get a liberal arts degree. And it has worked out in some ways. And one of the ways is I remember a lot of random historical stuff about engineering. And I can tell you a little bit about it and how I remember how stuff was that has sort of come back through. And hopefully I can show you some of these cool trends in our profession over the past 30 or so years. Quickly, what CoStar does, for those of you who don't know, we're a big commercial real estate data and product company. We do stuff, this is grabbed from another thing, but we do stuff, a good example of commercial real estate is when we bought our building in DC, we bought it from the Mortgage Bankers Association, who had it filled halfway, bought it for $40 million. We rented it to ourselves, so it was rented full way, 100%, and then sold it to an investment company for $100 million, making $60 million in the deal in the course of 6 months. And that's kind of at the crux of the industry we sit in the middle of. So we've got a bunch of products. We do a lot of advertising. You've probably seen, and you can thank us for Thor Ragnarok for revitalizing Jeff Goldblum's career with our apartments.com ad campaign, which was just featured on Saturday Night Live, which is pretty cool. We do a lot of data. We have a big data product. We have a bunch of analytics. And then the one thing I'll quickly give you as another anecdote about how cool CoStar is that we acquired apartments.com 5 or 6 years ago. And at the time, it was only 16,000 listings. It was kind of in a stalemate. And what CoStar did is we had all researched the entire inventory of multifamily properties. So our CEO's vision was to put all the inventory on into the app or into the site so that you could quickly find anything. If you looked at a building, you'd see it in apartments.com. And that basically was completely remade the entire apartments landscape for how people found apartment buildings. So it wasn't just that they were providing listings, it was actually that they were able to find anything. And so CoStar is a really, really cool dynamic place to work. It's been a great place. I've been here for 10 years. And it's been some very, very cool stuff and a lot of growth. So without any further ado, here's a quick view of all of our icons, of all the stuff you may or may not recognize. Probably apartments.com is the big recognizable one. And then I will talk to you about this. So this is really what I'm here to talk about. I have been working in the industry for 30 years. And when I was a kid, I started off with Apple IIs, which hopefully you guys, I don't know, you can find them on eBay. They're old computers. They run at like a megahertz. And we now gone to some very, very powerful machines that are on our phones. And certain visionaries have really taken us from here to there, right? And I'm going to talk about sort of the past 30 years through 3 sort of sets of anecdotes about 3 different visionary software leaders. And I want to talk about sort of how they evolve, what their leadership style is, and really what they've done and kind of the trends in a way that gives sort of some things about whether they're good leaders, whether they're good visionaries, and what they're up to. So history is made of people. That's why I'm not going to talk too much about the actual tech, but I'll allude to it, and I'll sort of hit these 3 people and talk about them. So there's the 3 folks I want to talk about are Ozzie, Linus Torvald, and Elon Musk. You've probably heard of most. Maybe you haven't heard of Ozzie. He's a little bit more on the older side. They made some very, very good technical decisions, very good instincts. And one thing I realized when I gave this talk the first time is it is about the least diverse talk you can talk about. And I've gone back and forth on that, but as it turns out, I do think that these 3 individuals do provide a very, very good review of the industry at the expense, however, of any meaningful amount of diversity, which is not really where we want to be going today, but it's the way things kind of were. So that said, I'll kind of jump in. You've got Ozzie, Linus Torvalds, and Elon Musk. Each of them is a kind of very unique person. So, and this is sort of a repeat slide, but first I'm going to talk about is alpha and sort of the correctness thing about them, right? So alpha for investments is really the ability to make good choices. So they say that the average person can kind of pick 50-50 and be good at stock picking, but alpha is the ability to consistently outperform the market, right? And that is a crucial thing when you think about making good technical decisions. a lot of people can make technical decisions. A lot of people can just, choose an iPhone, choose an Android phone or whatever. But when you sort of pick the right phone in the right time, you realize, and you look at companies that don't make missteps, like that's really a core component of that. And as you guys go through the industry and your careers, I think that is it, because I really found that being right is a skill. Like, it's not like you're right one time. You need to hone that ability to make the right decisions and the right technical choices over time, so that you can make, again, better choices and basically ultimately be a more effective leader. So that said, let's talk a little bit about Ray Ozzie. Now, Ray Ozzie, now I have really weird slide transitions in here because I'm not very good at it. Ray Ozzie developed a system called Lotus Notes, and this is what it looks like. It's old school. It's what I started my career on, in fact, in 98. It did some really cool stuff. It was a system that allowed end users to do their own development, drag and drop stuff on screen. It was really key. It had a multi-master replication, which was so far ahead of its time. A lot of the things that we're discovering now and or working through now involve multi-master replication, and they had a pretty impressive use of it way back when, in the 90s. I had a user-based designer for forms, and it had schemaless document-based storage. In the past 10 years, we've had this sort of revolution and pivot towards a lot of document storage, NoSQL. But it's really important to realize that Ray Ozzie sort of thought this up almost 30 years ago and had a system that did it. And granted, it was an atrocious system to program in, which I'll point out for a sec. But he created this actually in 1989. The cool thing, the place where I used it is I worked for a USAID consulting company right out of college, and they use it to actually replicate email to places that only had ultra low bandwidth connections. And it used its replication. So you'd write your email on one thing, it would actually replicate it to another server and then send it from there, which was a very, very cool application of technology. It had two programming languages, a macro language, which was very rough but serviceable, and a script called Lotus script, which is basically a ripoff of VB script, or a very similar thing. I don't know if it necessarily one took from the other. It ran on multiple OSs. It could run on Linux. It could run on blanking on what some of the other older OSs were, Windows, etc. It's client server. But some issues with it was way too early for end users to be their own programmers. There was Lotus Notes, there's SharePoint. There's a lot of things out there, especially things like Wix for web development, where you can drag and drop. But it is very, very hard for, the idea of an end user being their own programmer is something that hasn't really gotten to the point where it needs to yet. And you still see that coming out here and there. But it's a thing we try to crack in the industry many, many times. Multi-master replication turns out to be very complex for a user to interact with, because he would say like, hey, you've got a replication conflict now, unconflict it. Very, very challenged. Also, and it really wasn't aligned with other trends in software development, like modern source control. It was all in one, and it actually stored all this programming as a NoSQL document or a document store as well. So you had this whole thing where it has this built-in IDE, but it's stuck around. I mean, it's still there. It got Lotus sold to IBM. IBM sold to another company, and it's existed for years and years and years. The U.S. government and some very, very big companies bought in very heavily to it in the 90s. But it is there, and it's been improved. And it's, you sort of think about it that again, we're using Mongo, we're using CouchDB, stuff like that as one of our major document repositories. But this basically did it then. And in each row just kept adding records or columns onto it as you added fields to it. It was full text searchable, just like Mongo, all this stuff. And it could do multi-master replication, which is something that, a lot of the new NoSQL systems can do. So very, very cool to think about that 30 years ago, Ray Ozzie kind of thought this up and brought it to production and, made a business out of it, when we're actually revisiting a lot of these trends today. So Ray Ozzie then took over as chief architect at Microsoft after Bill Gates, and he spearheaded the creation of Azure, which is a very, very impressive resume, obviously. And it leads to some, it's a very cool overall career. And so when you sort of think about him, like, how do we look at him in his context? Like, so what did he do wrong? He had a very ambitious system. He made a lot of money and did very well for himself. So it's not that he did anything wrong, but it was sort of too early. And even the stuff he did then has not really been perfected today, which is sort of an interesting concept to sort of think about. of, sometimes you see an emerging technology and you say, well, is it ready to go? Which is a little bit challenging. So you have to sort of think about, like, how do you consider his alpha? Like, what is his overall correctness? It's pretty good. Azure's done very well. Microsoft obviously done very well. Lotus Notes did well and did some very cool things. And it's very hard because whereas for Linus Torvalds and Elon Musk, you have a lot more anecdotes about their leadership style. You really do see that he's had a very, very good, long career as a leader, and you would presumably want to work for him. So that's kind of the overall view of Ray Ozzie, and it is very impressive. You sort of, I think about some of the earliest software that I've written, going back and thinking if it's still in use today, and you realize that very few of us will be able to look back to the upgrade cycle and say, wow, that piece of software is still in use. But Ray Ozzie can look back and see all the stuff he's built that's still in use, which is pretty cool. Then we move on to Linus Torvalds, whom I assume most of you guys know who he is. Started working on the Linux kernel in '91. Unix itself had become paid, so he decided he was going to just start his own copy, and did so, and also invented Git while he was at it. So the guy really, some stuff that every single one of us is probably putting our hands on every single day, between the Linux kernel and Git. That's a pretty impressive thing. He also not only built the kernel, but he also guided it and splintered it into what it is today. He led to his growth and expansion, which is, it's a massive community, huge amount of money and resources go into it. And he basically, when you think about it, completely changed how the software industry operated. Software used to be top down, big things, very, very much like any sort of industry. You had planning and you had massive pyramidal structure. It wasn't very horizontal. And he completely changed around how it worked. So that you had a massive distributed kind of group-led thing that was being built. And I think he's probably one of the five most influential people in computer engineering. He really, really rethought how things were going to work. So whereas, you sort of look at Lotus Notes as a big monolithic piece of architecture that really is that way. It's a client-server app, and it's enormous, but it's all one thing. The Linux kernel is a lot of things in a lot of ways to a lot of people, which is a complete paradigm shift from the way software engineering was done then. He also figured out how to not only develop a kernel, which previously, it was a kernel because it was this tiny little tightly packed hub, and make it into a distributed thing so that it was modular and pluggable. And 96.4 of the top 1 million web servers are running on Linux. Not to mention, as I'm sure, like every Android phone and obviously tons and tons of servers you guys may have around. So just, unbelievable when you sort of think of where he took this and changed the way that the industry worked. However, you got to look at how his leadership style, which is he's kind of ironically highly centralized for a really horizontal thing. So you think about Git and you think about Linux as this big, broadly defined, described group thing where it's very, very broad, but a lot of pull requests go through Linus, a lot. And he's not a particularly nice person. And the next two slides are just stuff that Linus has said over time, including, and I'll read these two because they're never fun to go through. I'm a bastard. I have absolutely no clue why people ever think otherwise. Yeah, they do. People think I'm a nice guy. And the fact that I'm a scheming, conniving bastard who doesn't care for any hurt feelings or lost hours of work, it just results in what I consider to be a better system. And I'm not just saying that. I'm really not a very nice person. I can say I don't care with a straight face and really mean it. And you have to sort of say to yourself, well, here he's kind of in an ends justifies the means kind of a place, which I can kind of wrap my head around to an extent because of what he's trying to do. But on the other hand, people don't really relish being maintainers of parts of the Linux kernel overall. So here are some other choice things. He was messaging with a person about the audio system. He said, Maro, shut the expletive up. It's a bug, all right, in the kernel. How long have you been a maintainer? Are you, my Windows over here. You still haven't learned the first rule of kernel maintenance. Shut up, Maro. Do I ever want to hear that kind of obvious garbage and idiocy from a kernel maintainer again? Seriously. Fix your, quote, compliance tool because it's obviously broken. Fix your approach to kernel programming. Now, as we sort of think about how we want to have as an industry, you guys can glance through the second one because it's really just the same thing again. But this is a major thing that he's kind of known for. And, you sort of step back and you say, look, what is a very important piece of having a career and leadership is the idea of fostering a team. And that's one of the cases where, the Linux kernel has a lot of individual federated teams in its maintenance, but you don't really build a long-term healthy team organization with this kind of approach. And he is amazing at what he does. But on the other hand, this is a very rough way to say, hey, look, if he ever sort of went away, would he actually, have anyone who picked it up after him in the way he did, right? Because a lot of growing an operation is that. Here's a final thing. He really does not. He does not really want to fit into a mold of a leadership, despite the fact that he wants to actually do it because he puts a great amount of control over the overall architecture of Linux. So this leads to a situation where what I call the Patton syndrome. So Patton, the World War II general, this is the history major in me coming out, was an extremely talented leader. He was also, and I highly recommend watching the movie, but he was also bonkers. He thought he was the reincarnation of like all the great generals ever. But he didn't have a ton of regard for his team, and some of his downfalls were that he acted very, very poorly towards regular soldiers. But he always won. He was unbelievably talented as a general, but got passed over both by Eisenhower in World War II and by I can't remember his name, because he simply couldn't perform the leadership roles in anything other than a combat scenario. And in my opinion, you don't want to be this guy, right? Like, very, very strong alpha. I mean, when you sort of think about what Linus Torvald has done, he has really, really reinvented how the whole thing operates, how we do development at a fundamental level. We don't go into development in a waterfall. Like, so much of Agile and Scrum is based on the inputs of his approach to open source programming that really developed this. But on the other hand, would you want to be this kind of leader, and would you want to work for him? My tendency is there's a strong negative here that makes it so that you have to sort of analyze it in a hard kind of way that says, look, is this the right way to go into it? So last but not least, this is a reasonably, I've done this one a couple of times before, so I can move fairly quickly through this. But we have Elon Musk. And I have a unusually high regard for Elon Musk out of all the technological leader people out there. He's founded this thing called Zip2, sold it in 99, got 202 million. Then he built X.com, became PayPal, sold to eBay for 165 million, started Tesla, and then SpaceX. And so here's a person who has gone through tech, started as a programmer, developed into a leader, and then now is effectively a person who, in both of his two modern ventures, has completely redone how the entire industry operates. Again, right? So you look at this overall arc of the way Ozzie did it, which is to build very, very large systems in a designed way, much like the design of old, right? So back when they did any sort of industrial design of non-software engineering, it was done in a much more structured, formal way. Then you see that Linus Torvald's influence really changed to be a much more federated, much more kind of low-level people working on it kind of a way, and much more federated and horizontally integrated. So it was very wide. And if you look at what Elon Musk has done with Tesla and SpaceX, he has actually flipped a lot of this stuff back around to basically make it more like a highly efficient Henry Ford model than a modern software model. But it's blended the two together in what is really a kind of new way of approaching industrial design, both taking designing of stuff and making it more software-like and making and aligning these together. So he's a visionary, right? So the one thing you listen to whenever he says something is no matter what he says, it's generally a pretty good and useful idea. And he's always ahead of the curve, right? So this is a really interesting case. That if you look at him and you study what he's done, he rarely has a thing that is patently wrong, and it's almost always applicable. Like it's a doable solution, right? He sees the path to success, and this is a part of that alpha, right? So not only do you have to have a general sense of what you how to be right about the technical choices for any arbitrary project. Are you making the right technical decisions? But can you also see how to get it done, right? So like a project that requires 100 people to build, but you've only got 10, there's no path to success there. And so he can make these things on a very, very large scale. And in my experience, one of the very important pieces of being a software engineer and in a leadership position is you have to go and find a way to make your projects bigger and bigger over time and make them all successful, right? Because you don't want to be involved with a failed software project. CoStar does a lot of mergers and integrations work. And I've done 10 in my time, and they've been very, very large. And it's one of those things where it's a massive multi-piece, multi-team project, and you have to get it across the finish line. Most companies really struggle with mergers, especially on the technical side. Not only do you have to have a clear product vision, but you also have to figure out a way to get it actually done. So Elon Musk has actually been able to do that, and he sees how to get it done. And if you take apart Tesla, he looked at how to get the cars built in a very efficient way. And if you kind of look at what he's done with his with the gigafactories and all that, he's integrated everything in one place, making it so that you have a single large vertically integrated thing. And one interesting anecdote I read about SpaceX with the crew capsule was that the astronauts who were testing it had an ergonomic piece of feedback where they said, look, this panel would be better if you rearranged a couple of the buttons so that we can work with them better. And then they said, look, if you had been in NASA, you would have to have 100 meetings. You'd have to have committees of doctors and scientists and electronic engineers all go around to decide whether it was a good idea or not. It would take months and it would cost you millions and millions of dollars of changes under your contract. Whereas he said, well, they just pulled the engineers into the room, had to make the change, see if it worked, and they left it. And that was a ultra high cost way of quickly iterating over, a hardware software combined change in a way that makes it so that you actually can do the highly iterative agile software development in a hardware sense, which is very, very hard usually because hardware prototyping and mock-ups and all that stuff tend to take a lot of time and energy and a lot of resources too. So a lot of that is very, very clever how he's gone and taken from, if you go back and you say, well, the way that we used to build things, if you were going to build an airplane, you would make a bunch of prototypes, a bunch of sketches, a full design, build the airplane all at once, and then you see if it worked after a lot of design work. And then as you sort of look through the trend of Linus Torvalds, how he basically said, look, we now have to work much more, not him by himself, iteratively and deliver in little phases so we can actually see what we're doing as we go and course correct. Because obviously, as you can tell from like the 737 thing, they can make it, they can get a plane flying, but because they aren't really able to test it as thoroughly in the same way we do with software, you can run into some problems. And that's the very cool thing is that he's able to change his vehicles almost in real time in reaction to testing in a way that there's not a ton of, there's not a ton of parallels. And not only that, but he did it with space exploration. And I think what he's shown very clearly is that he's able, you can actually do it. Now, the question is it replicable outside of him? He's obviously got some very, very talented people working with him who can do this. So the other thing about him is the vertical integration piece. My father worked for Pratt & Whitney Aircraft building jet engines. And what he specialized in was the logistics of getting like a ton of companies, 70 to 100 companies, all their supply chain processes flowing together so they can assemble an engine. Same thing true anywhere in aerospace. There are these massive pieces of contracting. And that is that is sort of been the truth. Auto parts, the traditional American auto parts thing is built on a massive triangle of different part suppliers. And what Elon Musk said is, hey, look, they all need to be thoroughly integrated into the one company so that you have full control. Now, that's kind of Henry Ford's way of doing it, and it had changed over time to being these big webs of dependencies. And excuse me. And if you look at both Tesla and SpaceX, and I imagine the Boring Company too, everything is done in-house, except for certain parts of like mining the batteries. And that has provided them with this massive ability to change their velocity and increase how fast they deliver. And that's a really interesting, it's a very important thing is that where software first splintered off, software engineering and modern engineering splintered off from traditional engineering and became very agile and very iterative. Modern engineering really hadn't caught up to that until Tesla started saying, look, let's put it all together and iterate very rapidly. SpaceX, same thing. They iterated very rapidly over it in a way that actually got them a tremendous amount of velocity. So he has basically gone and said, let's take, originally we said, let's take industrial principles and apply them to software. And that didn't quite work, but we got it ironed out in kind of the middle section. And now they're taking software principles and applying to industrial building, which is really, really cool. And so that's what I said. So that what I was getting to is he's using software approaches to build physical things. And we in the software industry, having gone through this over the past 20, 30 years, have actually been using industrial principles like Lean and Kanban and Six Sigma, which as soon as you get into the workforce, you'll find people who are sort of adherents of all of these to make software. So we've been saying, hey, look, so Lean is basically the idea that you shouldn't have unnecessary waste in your process. Kanban is this idea that it's about constraints, that you want to make sure that the stuff moving from one tooling station to the next is in the same level as the next thing's capacity, so you don't get piles of semi-finished goods stacking up. And Six Sigma has to do with defect management, where the idea is if you make 1 million nuts and bolts, you would only want like 1 in a million to be in your defect range. All of these things that come from big manufacturing, we've been struggling over the past 20, 30 years to apply them to software. And now Elon Musk flipped it and basically, I'm going to take software ideas and apply them back into physical, which is, I think, his enormous breakthrough. But he might be crazy. For all the brilliant insight he has a real challenge with obviously he has some focus challenges, but when you sort of think about, do I want to invest in this guy? You leave yourself, he performs really well. Like you see this, but he also is really, really into the showmanship, which can be good and can be bad. And I don't know anybody, honestly, who works directly with him, although, you can sort of see the results. But it does make a very interesting case study, because he does have this personality, a little bit of this pattern, like this showmanship that really, aids what he does and motivates his teams in an unbelievable way. This sort of fail first and fail forward approach. But he also, crazy in space flight, I don't know if necessarily they go together. Would you want to be this kind of leader? I don't know if he's replicable. Is there something that you can say is that you could take it and reproduce it out of what he's doing? Is it something that you really can scale? Or is he just a one-off that is just so unusual that you don't know if you could, replicate it? Would you want to work for him? I think in general, most people would want to work in a place like that. But there are lots of stories about him working people to insanity, and in a very, very high pressure work environment. And it's one thing to be like tired at your computer writing software. It's another thing to be doing that on a shop floor with like robots whirring around you and stuff like that. So there's that piece. So I'm going to sum up. I'm going to keep this on the short side. I know you guys have all been hacking all weekend, and sitting and listening to a person go on for an hour with only a handful of pictures in the slide deck is probably not the thing you want to do at dinner time. But I'll give you sort of the general summation. I'll open up to any questions you guys might happen to have. But overall, I said it was about history. It's really about people and history. And the key thing is, it's up to you. It's up to you overall to see how you're going to evolve it. I think there are two core skills that exist within software, other than being a good engineer, which is sort of goes without saying. And the alpha speaks to that, right? It's if you're going to go and have an engineering decision, which you eventually will be making every single day, how little regret can you have at the end of your project when you're like, now I have to maintain it. And did you make all the right choices? And that is super, super, super important in engineering, I've found. A lot of times you get an idea that's really, really cool, cutting edge, brilliant maybe. But then you sort of think about it and be like, is this going to have legs? Is this going to last for a long time and really work well? And that's that thing is you look at some big pieces of software. And even if you look at Microsoft Windows, it has changed radically over the years as it evolves, whereas Mac OS really hasn't. And you can draw these contrasts throughout whenever there's two of a thing to sort of discuss. And that's kind of a real valuable thing to sort of consider, right? Is if you're going to if someone were betting on you, would you be right more than half the time, or how often can you do it? And the second thing comes down to leadership. Is you might have a great idea, but getting it done and getting it out the door in a way that is healthy for the people around you, right? Because I do think that no matter what we're doing in this industry, we're at a time where you can't be an abusive leader, and you really can't, have it so that you're not kind of as a member of a team in a leadership position. Your job does involve a level of stewardship and mentoring, and so if you do fall into the Linus Torvald's camp of being somewhat abrasive, you are doing the industry and you're doing your sort of engineering community a little bit of a disservice, which I feel that is a very important piece to sort of think about and reflect on. Because even if you have high alpha, you'll have some anomalies where even a rough, abrupt personality can get it there. But a lot of that comes from being able to persuasively convince other people to do what you think is a good idea. So that is my high-ish speed, 30-minute, 40-minute quick workshop. And I thank you guys all for listening. That covers what I have to say. If there's any questions, you can throw them. I'm on the Discord channel, or you can enjoy your evening.